Welcome to the Math Record. Today I'll be covering the ICTM Regional 2019 Division AA Geometry. For this video, I'll be covering question 7, question 11, and question 19. And I'll just take a minute to scroll down this entire contest if you want to answer the entire thing by yourself. Okay, so that's all 20 questions. So if you want to pause the video and answer them by yourself to prepare for the contest or whatever, that's fine. And let's start. Number 7. ABCD is a rectangular 8.5 inch by 11 inch sheet of paper. AB, so this line on top is 8.5. BC is 11, so that's on the side, that's 11. And then the next few lines just describe the picture. And they say that B to C prime to E is 30 degrees, okay? So the length AG is written in this form. So AG is this line right here. And we need to find the sum of all the coefficients, basically. So let's kind of draw a picture. Let's draw a little bit lower. So then, okay, and then something like this. Okay, so we know it's a rectangle. So this is 90 degrees, this is 90, this is 90, and this is 90. And they said that this is 30 degrees, and that gives us that this is 60. So if this is 30 and this makes up to 180, then this side is 60 and this one's 30. So this is important because we could just use the special right triangle, which is if this is 30, this is 60. Well, actually, let's put 60 here and 30 here. So if the length of here is x, then opposite of the 30 is half of that, so it'll be 1/2 x. And the opposite of the 60 is square root 3 over 2 times x. So we're going to use that property to answer this question. So we know that this length is 11, but since it's kind of folded, it's actually this plus this. So we could call that x, and we could call this 11 minus x. And remember, the opposite of the 30 is half of the hypotenuse. So x divided by 11 minus x. So the ratio of the side length of the 30, the hypotenuse is 1/2 x to x. So that's just 1/2. So cross multiplying, that's 2x equals 11 minus x. So that gives us that makes 3x equals 11, and 11 equals x equals 11 over 3. So now we could plug that into a picture. So 11 over 3. And 11 minus 11 over 3 is 22 over 3. And this gives us that our 60 is half and then square root 3. So half of 22 is 11. 11 times square root 3 over 3. Okay, so remember that our top is 8.5. So we could write that as 8.5 minus 11 square root 3 over 3. And now if we want to get this length, which is what we want, we see that we need to get from the 30 side length to the 60 side length, right? And what's the ratio between them? Well, to get to the 30 is this, to the 60, we have to get from 1/2 to square root 3 over 2. So all we have to do is multiply by square root 3. So multiply this entire length by square root 3, so that's 8.5 square root 3 minus 11 square root 3 times square root 3 is 11 times that 3, divided by that 3 is 11. And then to make this an integer, that is 17 square root 3 minus 22 over 2. And then we have to put that in the right form, so negative 22 plus 17 square root 3 over 2. And now you say A, B, C, and D. Now add them together. So that's 2, 5, 22 minus 22, 0. So that is your answer for number 7. And that's basically it. Okay, number 11. Quadrilateral QUAD has a vertice 4, 7, and 5, 2. So if I ever see coordinates, I like to plot them. And I notice that they're both positive, so I'm just going to go with the first quadrant. So 4, 7. So somewhere like, let's say up here. And that is point Q. So that's 4, 7. And we have A, which is 5, 2. So somewhere like down here. So that's A. So let's call that 5, 2. And then we have point D, which is 2y. Vertex D is at point 2y. And it's the least value of y such that QDA is 90 degrees. So we have to plot point D. And then when we plot somewhere point D, it makes like a 90 degrees. So let's kind of draw like a decent picture of where it's gonna be. Maybe like somewhere like right here. That would make the 90 degrees. Okay. Let's make this a little bit straighter to the right point. And that makes the 90 degrees. And this is point D, and this is 2y. And they also have vertex U that's on line x equal to 9. So let's say we have this line. We call x equals 9, and we have point U on it, such that the distance from Q to point U, which is on this line, to A is the shortest. So let's just say the point is like right here. Okay. And we draw a line, and then we draw another line. So the distance from here and here, we need to make it the shortest. Determine the numerical area of the quadrilateral. So we need to find the area of this. Okay, so this is U. So first, let's find our point D, because we know this is 90 degrees. So that tells us that the slope of this line and this line have to be opposite and reciprocal each other, right? Because that's the idea of perpendicular lines. So we have 7 minus y over 4 minus 2, which is 2, and then y minus 2, and then 2 minus 5 is negative 3. So opposite reciprocal will be 3 over y over 2, 3 over y minus 2. So I noticed that this y is positive and this is negative. I usually like to keep them positive, so put this a positive and this a negative. So since I multiplied this side by negative, I need to multiply this side by negative. And now I'll cross multiply, which gives me y squared, negative 9y, plus 14 is equal to negative 6, which gives me, move the negative 6 to the other side, which gives me a 20, and that makes a 0, which you could distribute, factor out as y minus 4 and y minus 5 is equal to 0. So your y is the smallest, remember, least value of y on question 11. So that means y is 4. Okay, so we did all that so we could prove that y is 4. So let's delete that bit. Okay, so that is 4. And now we need to look for point U. So we know that the x value is already 9. And let's just say its y value is y. Okay, so basically, how do we find this distance? It seems like a lot of work to find distance. So let's kind of think of it, how do we make this a straight line? Because it's a distance, right? So imagine instead of being bent this way, it continues going on. So we're going to have this line, and it has to flip over because we want it to continue going on. So what are we doing, basically, if we're making that? That means we're reflecting this line over to here. So we're reflecting over the x equals 9. So we're going from 5 to and going to 9. So it goes a distance of 4 from 5 to 4 to make the 9. So that means the 9 has to go to a 4 to make 13. So that point is got to be 13, 2. Okay, so that point is 13, 2. So basically what we have now is this straight line and this line, and we just need to look for the line of intersection. So basically we have the slope here, which is 7 minus 2, which is 5. And then 4 minus 13, which is negative 9. So I'm just going to put the negative on the 5. And then we have x, and then we just choose one of the points. I'll just choose 4 and 7. So x minus 4, and then plus 7. That's our y. And where does this intersect with? Well, we know that intersects at x equals 9. So just plug in 9 in here. So 9 minus 4 is 5. 5 times our negative 5 is negative 25 over 9. And then plus our 7, which is 63 over 9. And that should add up to a 38 over 9. So we found our y value using some logical ways of solving this. Okay, so that's 38 over 9. So that's our point for u, 9, 38 over 9. So how do we find the area? So let me just move this up a bit because we actually don't need this entire picture. And to get the area, all we have to do is just list down the points in order, so going counterclockwise. And then I usually like to start with the rightmost point, so 938 over 9. And then we're just gonna write it straight down. And then we have 4, 7. And then we have 2, 4. And then we have 5, 2. And then we have 938 over 9. So once you get back to the first point, you stop. And what we're going to do is we're going to think about each one as a matrix, and we're using something called shoelace theorem. So we have something like this, and then the 2 by 2 with this, 2 by 2 with this, and the 2 by 2 with this. So we're going to, each of these we make a 2 by 2 matrix, right? And then basically we're going to do the determinant. So 9 times 7 is 63, and then 4 times 38 over 9. Let's just keep it like that, 38 over 9, right? So 63 minus 4 times 38 over 9. And then 4 times 4 is 16, minus 14. 4 minus 5 times 4 is 20. And then 5 times 38 over 9 minus 18. So I know a 16 and a 4 cancel out with the 20. And then the 14 and the 18, the negative 14 and negative 18, that's negative 32. Cancel out with this one to make a 31. Right? And then 4 times 38 over 9 and 538 over 9 just leaves the 38 over 9, right? Because 5 minus 4 is 1. So we have a 31 plus a 38 over 9. And then this, basically we just added all these together. So when you add all these together and take half of it, that gives you the area. And that's the idea of the shoelace theorem. So this one is 279 plus 38 over 9, and then times a half. So just move the 2 on the bottom. So this is going to be 17, 1, 10, 1, and then this is 317 over 18. And that's your answer for number 11. Okay, now the final question, number 19. So ABCD is, ABC is a right triangle with CAC is perpendicular with BC, and line D lies on AB such that CD is perpendicular with AB. Okay, so let me draw the picture. And we have a right triangle, and then we basically make another height. And then we have AD, which they gave us is 10. BD is 2x. Our BC is x plus 5. And we need to find the length of CD. So CD here. So we'll call that H. And it's in the form k squared root w over p, and we have to add all the coefficients. So basically, this triangle is what I refer to as a right triangle in a right triangle, because there's a right triangle here, and right triangle here. And you could use a bunch of similarities because basically this angle, if you call this, let's say theta, right? Then this is 90 degrees, then this is 90 minus theta. So if you make a 90 degrees with this, that means this one is theta. And then if this is 90 degrees, right, then this is 90 minus theta. And you could just use a bunch of similarities because this angle goes with this one goes with this, right? So the smaller angles also, the smaller triangles make with congruency, and there's also the bigger triangle. So you could just make a bunch of congruency together with ratios. But basically, if you do that, what you find out is that h squared is equal to the multiplying the parts of these two side lengths, and that's 2x times 10. And you also find out that this side squared, x plus 5 squared, is equal to this part under it, which is 2x, times this entire side length, which is 2x plus 10. So expanding that out, that's x squared plus 20 plus 10x, plus 25 is equal to 4x squared plus 20. So moving everything to one side, we get 3x squared plus 10x minus 25 equals 0. So 3x, and we have an x. So we have a plus 5 on here to make the 15, and then minus 5. 15 minus 5 is 10, so that's perfect. X cannot be negative, so x has to be positive over here, 5 over 3. So we have our x value. Now we could plug it back into here to get our h. So that's h squared is equal to 5 over 3, well, 2 times 5 over 3 times 10. So that is 5 times 2 is 10. times this 10 is 100 over 3 equals h squared. So then to get h, which is what we're looking for, just take the square root of that. So square root of 100 is 10, and then square root of 3 on the bottom, square root 3. And then you can just multiply both sides by the numerator and the denominator by square root 3 to get 10 square root 3 over 3. And and 10 is your k, your w is 3, and your p is 3. So adding them all together, and you should get an answer of 16. And that's basically it. Well, that basically covers everything for this video. So thanks for watching, and I'll see you at the next math record. Well, before I leave, I'm just gonna give you the answers for this entire thing, just in case you want to solve everything. Okay, see ya.